All right, good evening, folks. So we're looking at more factoring methods for polynomials. This time we're looking at sum and difference of cubes. And the one thing about these is that it's a formula base, meaning that your expressions are going to look either like this with a plus, or it's going to look like this with a minus, okay? The solution or the answer we're looking for is going to be two sets of factors. One is a linear binomial, one is a quadratic trinomial, okay? Notice one thing about this is that if this is plus, and this is minus. If this is minus, this is minus, this is plus. Okay, and that's the biggest thing. Now, the one thing about these is you have to know your cube roots, but if you don't know your cube roots, use your calculator, and I'll show you how to find a cube root in a calculator if you're not sure. But the main thing about these is the fact that just like everything else, you've kind of seen maybe, is the fact that you always want to look for a GCF first. Okay, because it's going to simplify what we want to do something different to cubes. Okay, so here's what we have, and it's going to be a simple one. We're going to have two values, a and b, that we want to figure out. Okay, and if you look at the way this is written out, where it's x cubed plus 8, that means it's going to follow the first one where this is a and b. So a and b are going to be the cube roots of both of these terms. So, for example, the cube root of x cubed is going to essentially just be x. Okay. The cube root of 8, what you're asking is what times what it gives me 8 if I multiply 3 times the same number. So if you don't know how to do cube root, that's okay. There's a couple ways you can do this on a calculator. Under math, number 4, there's a cube root of 8. That'll work. That gives you 2. Okay. You can also take the number, raise it to the 1/3 power. Just kidding, it's not the 1/3 power. 1/3 power, and also get the cube root. So either way will work, whichever one you're familiar with. But what that tells me is that this right here is going to be 2. So essentially, this is going to be the same thing as x cubed plus 2 cubed. Okay, just like that. So then once we have that, we know what a and b are. So now we go to our formula, and since we know it's plus, so we're going to write it. The first part says where it says a plus b. So the first factor is going to be x plus 2. Okay. The second factor says a squared. So a squared will be x squared minus a times b. So 2 times x, or x times 2, plus b squared. Well, b squared, we know b is 2. So b squared is going to be 2 squared, which becomes 4. So then this will become plus 4. And there is your factors for summing difference of cubes. Okay. So what happens when you have a number like 3? Well, 3, if I try to cube root 3, it's going to give me an irrational number, a decimal, which I don't want. So what that probably means is there's a possibility that there's a GCF I can take out. So if I divide both of these by 3, what that's going to give me is x cubed plus 27. Well, 27 can be cube rooted, to 3. So it's the same thing as x cubed plus 3 cubed. Well, a, we know has to be equal to x, and b has to be equal to 3. So again, this is x cubed plus 3 cubed. So a cubed plus b cubed is the formula. So the first set, it says a plus b. So we have x plus 3. And then it says a squared. So x squared minus ab. So 3x. Sorry, I'm off. plus b squared. Well, b squared, we know b is 9, so b squared has to be 9, so plus 9. Okay. And there's your sum of cubes. Okay, same difference. X cubed and 64, so what's the cube root of 64? And again, I'm just going to show you again. Is 4. So this is the same thing as x cubed plus 4 cubed. Sorry, not plus, minus. So we know that a is x and b is 4. So it's a subtraction, which is this one here, so a difference of cubes. So we have a minus b. So x minus 4. A squared. So x squared. Plus ab plus b squared. Well, b squared is going to be 16. Okay. So what happens when you have a number in front like this? Well, first of all, can you cube root 125? You can, it's 5. And can you cube root 8, which we know we can because we did that earlier, to 2. So essentially, this is the same thing as 5 cubed x cubed minus 2 cubed. So a is going to essentially be 5x, and b is going to be 2. Now, don't worry about the minus sign. Okay, we're just going to use the value of 2 itself to do this. So again, it's a difference of cubes. So the first one says a minus b. So 5x minus 2 is a minus b. Okay. A squared, this is where it gets a little tricky. So 5x squared, which becomes 25x squared, minus plus a times b. So 5x times 2 plus b squared, which b squared, we know b is 2, so 4. So I can simplify this one more time where it's 5x minus 2, 25x squared plus 10x plus 4. Okay. Okay. 16x cubed plus 250. Well, again, can 16 be cubed root? It cannot. It is 2.5. So that means I can probably GCF something out of this. 16 can be 2, 4, or 8. So I guess the question is, if I take 250, I can divide by 2. 250 can be divided by 4. No, 250 cannot be divided by 4, because that's 62.5, so it's not 4. Can 250 be divided by 8? Nope, it cannot. So it has to be 2. So if I divide everything by 2, I realized I forgot to do one thing on one of my prior problems. On number B, in the very beginning, since I divided by 3, I have to make sure and put that 3 back as if I was going to multiply it back. I knew I forgot to do something. Okay, so that only happens if you take a number out, divide a number out at the very beginning. So like here, I'm going to divide by 2 to make this 8x cubed plus 125. I'm going to have to put this 2 back here at the very end. So 8 cubed is the same as 2 cubed x cubed. 125 is 5 cubed. So a is equal to 2x, b is equal to 5. So again, I set it up. This is going to be a plus b, so 2x plus 5. Then a squared, so 2x squared, minus a times b, so 2x times 5, plus b squared, so plus 5 squared. And then again, if I fix this up, that's going to become 4x squared minus 10x plus 25. Okay, so that's sum and difference of cubes. Now, how would we put all this together? We've done grouping, we've done sum and difference of cubes, so now we're going to do a problem that involves everything. Okay, so the first thing I'm going to do is group, since I have 4 terms. And again, I'm just going to group accordingly. So the GCF of the first one would be x cubed, and then that becomes x squared minus 9. The second one, my GCF looks like it'd be 8 plus 8, and that would be x squared minus 9. So here's what you have. You have x cubed plus 8, x squared minus 9. Okay. So sum and difference. This is a sum of cubes and the difference of squares. So I'm going to do this part first, where a is equal to, b is equal to x, b is equal to 2. So for this first part, I'm going to do, and then this one right here is going to become x plus 3 and x minus 3. That's difference of squares. So to write this whole thing out, this is what it's going to look like. I'll have x minus 2, a squared plus ab plus b squared times x plus 3 and x minus 3. So that's a full factor of the problem. Okay, and if I could take this one further, I would, but I can't. Okay, same thing, group. So 8x cubed, which leaves me with x squared plus 1. This is going to become minus 1, which leaves me with x squared plus 1. Now, this is a sum, so I can't really do anything to this guy, so he's going to stay the way he is. But 8x cubed minus 1, x squared plus 1. This is a difference of cubes, where a is equal to 2x, b is equal to 1. So, hold on. Backtrack. On this one right here, I just realized this was a sum of cubes. I was just looking at it right now. So this should be plus, and then this one over here should be minus. I apologize for that. It's the sum of cubes because it's a plus 8. This is a difference of cubes. So it's a subtract 1. So then this becomes a minus b. Then a squared plus ab plus b squared. And then the last one I can't do anything to, so that's the full factor for this. Okay. I apologize for that little mishap. Okay, there you have it. That's sum and difference of cubes. And the last two being with grouping. I'm just trying to think if there's anything else. You don't have to memorize the formulas, these formulas right here. So that's always a good thing. And I think that's pretty much it, y'all. Like I said, that little mishap, I wasn't paying attention to that. So, all right, well, that's pretty much all for this afternoon. So we'll see you around.